Good afternoon. This is Clifford Smith, lead dev at PRüF. It's February 22nd, and I'm here to have a developer discussion. What I want to talk about developer-wise today is going to be Solidity 0.8.1 specifically, but 0.8 in general. The changes that brought and what that was like migrating our contracts. We have 26 main contracts in the PRüF infrastructure, somewhere between 10 and 20,000 lines of code, and we got that migrated, finished that yesterday. At any rate, before I get started with that, I want to say, wow, congratulations, humanity. We managed to drop a Jeep-sized rover on another planet with a helicopter on it, and we dropped that down on cables from a rocket-powered hovering UFO. So that's pretty exciting stuff. I'm impressed that we pulled that off again, and I'm really excited about what information that exploration might turn up. That's exciting stuff. Those are first steps in a very, very long journey, and that's exactly the kind of thing that we as a species, as a culture, as a civilization, or as a group of civilizations, as a global civilization, need to be working on, because that is the direction forward. Ultimately, we have a lot of problems here at home. Some people say, oh, we shouldn't be worried about space until we solve our problems here at home. Well, call me a cynic, but I'm pretty sure we're not going to solve our problems here at home anytime soon. Human nature kind of dictates that we're likely to continue to have problems, and if we solve some, we'll probably invent new ones. But the thing is humans have always excelled and always been able to pull out just a little bit more when we had a frontier to explore. Also, it's sometimes frontiers have brought out the worst in people as well, but they at least bring out the extremes in humanity and keep us away from mediocrity. So as we explore outward, I think that we're opening opportunities, opening doors for ourselves, for our future generations, for our sons and daughters, and those doors are going to need to be open, because we're going to need to expand. We're going to need to get off the planet. Frankly, I don't have a lot of faith in being able to not destroy ourselves indefinitely. It seems to be something we keep getting up on the verge of one way or another, either through ecological disasters or outright genocidal war tendencies. We've got we've got enough nuclear weapons to wipe everybody out and destroy everything. And hopefully we have the good sense not to use it. But, how long can you play that game before somebody does use them? So, and even a small, nuclear exchange would have devastating effects on the global ecosystem, and it's already under a lot of stress. We're looking at stresses from climate change, from ecological damage, and from just from straight up human expansion and utilization of resources. We're a very hungry species, and that's not going to change anytime soon, I don't think. Anyway, I guess that's my little rant off on space exploration, but mostly I'm excited about that achievement of landing that probe, and I'm excited to turn up or to find out what it turns up while it's there. I hope it lasts a good long time. We've had pretty good luck with that in the past, and hopefully we continue to have luck with extended operational windows. At any rate, back to the main subject here, and that is Solidity 0.8 and the changes that it brings and our experiences in upgrading our contract infrastructure. Now, there's quite a bit of stuff quite a bit of minor details that have changed, especially in type congruency and implicit type conversion. So that stuff you'll definitely want to go into the docs on. I'm not going to cover all of that here. The biggest one there that was relevant to us and will be relevant to a lot of people is the change from any literal addresses being interpreted as type address. Instead of that, literal addresses, I'm sorry, previously literal addresses were interpreted as type address payable. So if you literally wrote out an address in your contract, that address was payable. If now under 0.8, if you have a literal address, its default type is type address. So if you want to make it payable, you have to go in and do a payable, brackets, then the literal address. So that'll convert it over to a payable address. So if you've got any literals that you're paying, we don't have anything like that in our contracts, but if you do have any literals that you're using as payable addresses, you'll need to make that change before you deploy them using the 0.8 or above compiler. Let's see. Other than that, there's a few changes in the order of operations. I won't be going into the details on that because I think that if that's relevant to you, you need to look at the docs and figure it out exactly how that's going to impact your code. My personal advice in order of operations issues is because of this very thing that you can have changes in a compiler that might change the order of operations. I always make any order of operations explicit. I just put my parentheses where they're going to go and make it explicit the order that my code is to execute and my calculations are to be performed, whether or not it's necessary. That just makes sure that things are grouped together. Incorrect comparisons or calculations are not made, and it doesn't matter how the compiler changes in the future. I won't end up with a hidden bug that is very difficult to find sometimes that may subtly change the behavior of my code. So my recommendation is to use explicit ordering of calculations, but if you do want to use implicit ordering, it has changed from the pre-0.8 to 0.8 and above, and you will want to look into the docs and figure that out. Other than that, let's see here. Bunch of type conversions that used to be able to be implicit now have to be explicitly converted. And other than that, let's see here. Okay, one of the big ones is that I'm sure that most of you are probably familiar with Safe Math. It's the library. The most common one that people use is out from Open Zeppelin, and it is designed to protect against underflow, overflow problems with mathematical calculations, because by default, the default behavior of Solidity was just to roll over any underflow or overflows. So that could cause problems with balances, for example. If you're reducing a balance of something and it goes below 0, well, then it would go to a unit 256 fully populated with ones. So that would be a big balance. So that could cause some problems. So the default behavior has been changed from rolling over on an underflow or overflow condition to reverting. So now if you have an underflow or overflow, it will revert. So that's the same behavior as you had with the Safe Math library. So you'll be able to get rid of Safe Math and go in there and replace those dot adds with plus with addition symbols, and be sure and catch your parentheses, because that trailing parenthesis will catch you up if you don't get both sides of that dot add argument. Anyway, so all of your math can be converted to that. Now, some of you might be using that rollover behavior intentionally, especially with bytes. That's real common, where somebody gets a byte and they want to increment it, and they want it to automatically roll back to 0 as it increments out above 255, or go to 255 if it decrements down below 0. That behavior will now cause a revert. So if you have that, if you're using that behavior in your code on purpose, you will now need to surround it with a function, or with a label called unchecked. So it would be unchecked curly brackets around the thing that you don't want to throw on underflow or overflow. You want it to go ahead and underflow or overflow wrap around seamlessly. It needs to be inside the unchecked curly brackets. So check the docs on that, but that's another big change that is going to affect some people more than others, but it was definitely something that we utilized. It's kind of nice to get rid of safe math. It hides, it gets rid of a lot of hidden code complexity. So even though it doesn't look much more complex, it's calling functions from other contracts, and you can never be 100% sure how that's going to work out, especially if something changes in your inheritance and you weren't aware of it. So it's good to get rid of that, but keep in mind that you will need to use the unchecked if you're going to use that rollover behavior. Like I said, there's some minor changes to order of operations. My suggestion is to make that explicit. That way you're immune to any future compiler changes. Other than that, the big one is ABI encoder v2 is fully rolled out into production in 8.0 and above. ABI encoder v2 gives you the capability to pass strings and structs between contracts. So whereas before you could send a string to a contract, or you could receive a string as an argument from a contract, but you could not call a contract with another contract and receive a string or a struct as an argument in that contract. This has changed. This behavior has changed with ABI encoder v2. Now it's possible to call a function in another contract and have it return a struct or a string to the calling contract. This is a really big deal for us. We have, like I said, a fairly large network of contracts, a lot of code, and the necessity to move fairly good-sized chunks of data around between these contracts when some functions are being performed. So the ability to use a struct instead of passing a list of 8 or 10 arguments is huge for code security, for safety, and for auditability. Just to explain that, say we have a contract A calling a contract B, and we're calling the foo function in contract B from contract A. So let's say foo returns 4 variables, A, B, C, D, and contract A is looking for those return variables. Well, if they're all the same type, and you happen to return them out of order, that isn't necessarily going to show up. If contract A is expecting BACD and contract B is returning ABCD and they're all the same type, that function is going to work, but it's going to have the wrong data. So that is an issue with complex systems that use multiple contracts and networks of contracts. They can cause bugs that can be difficult to debug. Sometimes those are really obvious, and the result is obviously doesn't pass the sanity sniff. But sometimes, things can be much more subtle than that, and you could end up with a situation where a function appears to work in the test cases, but in other cases, or maybe only in some corner cases, may malfunction in a particularly destructive way. So being able to pass structs between functions, between contracts, I should say, is a pretty big deal, because that enables you to make sure that the structure of the data, that the order of the data is correct when you receive it, and the order of the data is correct when you send it. So that makes sure that you get the answer that you're looking for when you're calling a function in another contract. So that's kind of a big deal too. You have to keep in mind if you're producing something that you think will be called from foreign contracts, keep in mind if you're returning a struct, they'll have to compile with 0.8 or above, or they won't be able to receive that information. So keep that in mind. I don't think that's going to be too much of a factor, because I think people will be compiling with 0.8. But just in case, keep that in mind. Anything before 0.8 will not, well, if they use ABI encoder v2 experimental, they could still do it, but it would have to be compiled with that in mind. So anyway, that's a pretty big deal. It's going to make for much smaller code for us. We lost hundreds of lines of code by being able to pass structs. So that was great for us. Reduces complexity, decreases testing times, and it And if we ever had any debugging issues to work out, it's going to be much simpler knowing that the data that you're asking for is the data that's being sent. Because if you can't know that for sure without spending 15 minutes tracking everything down, well, that's a big overhead cost. Other than that, there was some stuff that some keywords that got removed. The log 0 through log 4 were removed. You'll have to replace those with the inline assembly. Other than that, there's a few other things. You probably want to go in and check out the docs, but mainly those are the things that we ran into. Migration, even for a large system like ours, was fairly straightforward. We're pretty detail-oriented when it comes to naming conventions and things like that, so that everything is very modular. But we were able to update our contract infrastructure over a period of about 6 hours. I was able to do that work of upgrading everything to 0.8, which included some pretty good-sized chunks being cut out and just replaced with struct passing instead, which was really nice. And I've put all those contracts through preliminary tests now. We have about a week or a little more of detailed testing to do now that we've made those changes before they're ready for the audit pipeline. But I'm pretty confident that everything's going to pass at this point without any problems. I was able to do all that, and actually we turned up 0 bugs in the basic functional and error tests that we run after every code modification. And so far those have been 100% predictive of functional utility, but we have a lot of other tests that we run. It takes several days to run all of the tests just to be sure. And I recommend that anybody that's working with programmable money should be at least as paranoid as we are about everything working right. And for every line of contract code that we write, I would say there's at least 10 lines of test code. So we're big on testing. And I recommend if you're working with programmable money that you should be big on testing too. Something you get one chance to get it right, and if you don't, then, well, it's a problem, generally speaking. Anyway, that's about it, I think. I hope that you're having good luck in your contract migrations. If you're a newbie and you want to know something that you don't know, or you just got a question, or feel free to drop something off in the comments here. I'll be glad to answer it if I can, and try to point you in the right direction if I can't. And remember, there's always Stack Exchange. Anyway, happy developing, and have yourself a great day. Bye-bye.